If you think method of joint is a difficult topic or challenging to you, then you should watch this video through till the end, because I'm going to break this down into 3 simple steps, and by the end you should be able to feel confident in solving these problems. So for this type question, the first thing that you will notice is you'll have some reaction to solve, and in this case it's RA and RB. And what you're usually required to do is to take the moment about one of these points. I'm going to use about point A. So that means we're going to have RA rotating counterclockwise and RB rotating clockwise. So we're going to do the sum of the moment about point A. And when you see equals 0, it means that you expect the system to be in equilibrium. So what we have then is RB, and the distance of RB from point A is 8 meters, so RB times 8. We have the 12 kilonewtons going counterclockwise, so we're going to have 12 multiplied by 4. Those are the only 2 forces we have, so all of that equals 0. And if we were to just solve this, then 12 times 4 is 48, and RB times 8, so we divide 48 by 8, so that gives us 6 kilonewtons. So we know that RB rather is 6 kilonewtons. So that's RB done. Now to find what RA is, we just do the sum of the vertical forces. So sum of the vertical forces again equals 0. So if we do RA plus RB, and those are going upward, and then because that 12 kilonewtons is going in the opposite direction, we just subtract that. And we already know what RB is. So if we do RA and RB is 6, 12 there equals 0. So when we solve this, we're going to get RA again as 6 kilonewtons. And that's not a coincidence, because the system is a symmetrical system. So we expect that these 2 reaction forces would be equal to the same value. Now, one last thing before we move on to find the forces in each member. We're going to assume that every member is in tension, and that means we're going to draw the force arrows pulling away from the joint. And if the answers come out as positive, then the member is really in tension. But if it comes out as negative, then the member is in compression. So yeah, don't fight the sign convention. Let the maths tell you which way the force is acting. I'm just sketching this half here just so you can see exactly how simplified this is going to be. So we have this sort of setup for that half to the left side of the truss system, and we know that the vertical, the height there is 3 meters, and between A and B, where that apex 12 kilonewton comes down from point C, then that's 4 meters. So we don't even have to calculate the hypotenuse here, because it's just going to be 5 meters if you are aware of our 3, 4, 5 triangles. And then what we do with this now, we're going to do sine theta equals, so it's opposite over hypotenuse, so 3 over 5. So sine theta is 0.6. And if we were to do cos theta, again, this one is adjacent, so 4 over hypotenuse, 5. So that will give us 0.8. So anywhere in our maths where we have sine theta, we're just going to replace that with 0.6. And where we have cos theta, we replace that with 0.8. So I'm going to start at joint A. So this is just a sketch of joint A. So that's the reaction force. So that's RA, 6 kilonewtons. Right there, that's AB, and that's AC right there. So we intend to find AB and AC. So to start, I'm just going to do sum of the vertical forces should be equal to 0. So we're going to sum the vertical forces now. And for this, what we have is RA, plus we're going to have a vertical force component of AC, so we're going to do F AC. And because it's vertical, we use sine theta, and that equals 0. So we already know RA is 6, plus we don't know FAC, and I did say that we would replace sine theta with 0.6. So this is the maths that we have now to solve. So FAC would be equal to, so that's going to be negative 6 over 0.6. So that should be negative 10. And it means that this member is compressive. So what I would have to do now is go back to my diagram and just draw that arrow like that. So AC is compressive. So now we have AB to find, and for that one I'm gonna just do the sum of the horizontal forces equals 0. So FAB, that's just a purely horizontal component, so no cos or anything to that. And then we have FAC, and this is a diagonal line, so we're going to have this cos theta, and that's the only two members that are going to have horizontal components. So if we just write then FAB, which is the unknown, plus we know FAC as negative 10, we know cos theta as 0.8, so that's 0.8 there, and all of that equals 0. So now FAB 0.8 multiplied by 10, and that's now going to be positive, so that's going to give us 8 kilonewtons. It's positive, so it means that this is a tensile member. And just before we go on to the next joint, if you could give the video a like and subscribe to the channel if you haven't done so already, I'd appreciate that. And finally, if you're interested, then I do one-on-one lesson. If you have any exams working on, any coursework, that sort of thing, just book a session. The link is in the description. So the only unknown that we have now is BC, and I'm not gonna draw this one out. Let me just clear here to make some space. So joint B mirrors joint A. That's a fair observation. Now force BC would then be equal to FAC. So all of this should be negative 10 kilonewtons if we were to do that. So it means then that BC is also compressive. Now if you'd like to take this a step further, then check out one of these videos where I break down a much more challenging truss system step by step. If you've enjoyed this one, you'll definitely love that next video, and you'll learn a lot more as well. So check that video out, and I'll see you there.